How did the universe get started? How did it become the seemingly limitless place that we are familiar with today? And what will happen to it in the distant future? These are the difficult questions that have baffled thinkers and academics for ages, inspiring some rather crazy and intriguing beliefs. The predominant view among cosmologists, astronomers, and scientists today is that the physical rules that control our expanding cosmos, as well as the majority of matter, were produced during the creation of the universe as we currently understand it. This is referred to as the Big Bang Theory. For nearly a century, scholars and non-scholars alike have used the term interchangeably. This should come as no surprise, given that it is the most widely accepted theory about our origins. But what does it all mean? How was our universe created in a massive explosion? What evidence exists for this? And what does the theory say about the universe's long-term prospects? The theory's fundamentals are straightforward. In summary, the Big Bang hypothesis states that all current and past matter in the universe appeared at the same time, roughly 13.8 billion years ago. At this point, all matter had been compressed into a very small ball of infinite density and intense heat known as the singularity. The singularity suddenly expanded, and the universe as we know it began. While this is not the only modern theory of how the universe came to be, the steady-state theory and the oscillating universe theory, for example, it is the most widely accepted and popular. The model not only explains the origin of all known matter, the laws of physics, and the large-scale structure of the universe, but it also accounts for the universe's expansion and a variety of other phenomena. Working backwards from the present state of the universe, scientists hypothesize that it must have begun as a single point of infinite density and finite time that began to expand. According to the theory, the universe cooled sufficiently after the initial expansion to allow the formation of subatomic particles and, later, simple atoms. Giant clouds of these primordial elements later gravitationally coalesced to form stars and galaxies. This all started around 13.8 billion years ago and is thus considered the universe's age. Scientists have constructed a timeline of events that began with the Big Bang and has led to the current state of cosmic evolution by testing theoretical principles, experiments involving particle accelerators and high-energy states, and astronomical studies that have observed the deep universe. The earliest times of the universe, however, ranging from approximately 10 to the power of -43 to 10 to the power of -11 seconds after the Big Bang, are the subject of much speculation. Given that the known laws of physics could not exist at this time, it is difficult to imagine how the universe could have been controlled. Furthermore, no experiments that can generate the types of energies involved have been conducted. Still, many theories prevail as to what took place in this initial instant of time, many of which are compatible. Deep space observations in the early 20th century provided the first indications of the Big Bang. Vesto Slipher, an American astronomer, measured the Doppler redshift of spiral galaxies, then thought to be nebulae, in 1912. In almost every case, spiral galaxies were observed to be moving away from our own. The Friedmann equations, which were derived from Einstein's equations for general relativity, were developed by Russian cosmologist Alexander Friedmann in 1922. Friedmann's work demonstrated that the universe was likely expanding, contrary to what Einstein was advocating at the time with his cosmological constant. Edwin Hubble's measurement of the large distance to the nearest spiral nebula in 1924 demonstrated that these systems were, in fact, other galaxies. At the same time, Hubble began working on a series of distance indicators with the Mount Wilson Observatory's 100-inch, 2.5-meter Hooker telescope. Hubble discovered a relationship between distance and recession velocity in 1929, which became known as Hubble's law. Then, in 1927, Georges Lemaitre, a Belgian physicist and Roman Catholic priest, independently derived the same results as Friedmann's equations and proposed that the inferred recession of galaxies was due to the expansion of the universe. In 1931, he expanded on this, claiming that the current expansion of the universe meant that the further back in time one went, the smaller the universe would be. He contended that at some point in the past, the entire mass of the universe would have been concentrated into a single point, from which the very fabric of space and time would have emerged. These discoveries sparked a debate among physicists throughout the 1920s and 1930s, with the majority arguing that the universe was in a steady state. In this model, as the universe expands, new matter is constantly created, preserving the uniformity and density of matter over time. The idea of a Big Bang seemed more theological than scientific among these scientists, and accusations of bias were leveled against Lemaitre based on his religious background. Other theories such as the Milne model and the oscillatory universe model were also advocated at the time. Both of these theories, which were based on Einstein's theory of general relativity, which Einstein himself endorsed, held that the universe follows infinite or indefinite self-sustaining cycles. After World War II, the debate heated up between supporters of the steady-state model, which had been formalized by astronomer Fred Hoyle, and supporters of the Big Bang theory, which was gaining popularity. Ironically, it was Hoyle who coined the phrase Big Bang during a BBC radio broadcast in March 1949, which some mistook for a dismissive slur, which Hoyle denied. The observational evidence eventually began to favor Big Bang over steady state. The discovery and confirmation of cosmic microwave background radiation in 1965 established the Big Bang theory as the best theory of the universe's origin and evolution. So that's the end of the video. Make sure to like the video, subscribe to our YouTube channel, and press the notification bell so you never miss out on our next videos. Until the next video, take care.